Hello everyone, this is the video continuation for the chemical reactions of amines. Now in this video, I'll be discussing the oxidation of alkenes by KMnO4. This reaction is also known as hydroxylation reaction. Now what is hydroxylation reaction means? The addition of OH group to the carbon across the carbon to carbon double bond is known as hydroxylation reaction. Now let's check out the reaction. CH3 CH double bond CH2. Now the first oxidation reaction by KMnO4 would be R when KMnO4 is used. Now when KMnO4 is used, oxidation is used along with hydroxylation, means there would be addition of water is used because the KMnO4 and then the water itself is here. Now we know that hydroxylation of water, addition of OH group. Now what is the role of KMnO4 in this reaction? Means the KMnO4 provides nascent oxygen, therefore this oxygen comes and adds up with this hydrogen, and therefore it would form, when H2O reacts with another oxygen, it would form HO, and then this is formed. Therefore when there is addition of this molecule to the carbon to carbon double bond, therefore if OH, now simply there will be breakage of one of the bonds. Therefore if one bond is broke, it breaks up in this way. One group takes up one OH group, another group takes up one OH group. Therefore our product here would be CH3. Since only one bond is remaining, CH3 CH single bond CH2, one OH comes and join up there, the other OH comes in there. This is also known as vicinal diol. Vicinal diol means the two OH groups are attached to the same carbon atom. Vicinal means different carbon atoms. Therefore this is also known as vicinal diol, or it is also known as glycol. Now this is the reaction of alkenes with KMnO4. Now here, when KMnO4 reacts with alkenes in this reaction, the color of KMnO4, the purple color, the color of KMnO4 is purple in color. Now when the KMnO4 reacts with the alkenes, the purple color of KMnO4 disappears, which indicates that KMnO4 providing nascent oxygen is used up in this chemical reaction. Therefore this reaction is used as a laboratory test to identify the presence of double bond, that is our alkenes, in a reaction mixture, and this reaction is also known as Bayer's test. Therefore in this way KMnO4 is used, also known as Bayer's test, is used for identification for the presence of alkenes in a mixture. Now what happens when it reacts with hot KMnO4? Now when hot KMnO4 and alkene here, hot KMnO4 is used, oxidation occurs here in this process. An aldehyde oxidation occurs here. Aldehyde is formed, and then two molecules of aldehydes is formed, and further oxidation takes place, which results in the formation of an acid. Now here, when hot KMnO4 is used for the oxidation of alkenes, full oxidation takes place in this reaction, because the alkenes are first oxidized to aldehydes and then acid. Therefore full oxidation reaction takes place in this type of reaction. Now if we can write this carbon to carbon double bond H and then CH3, this it can also be written in this form, CH3, another CH3 can add up here. Now when oxidation takes place, just break this bond and add oxygen, we'll be getting C double bond O CH3 plus, even for this C double bond OH and then CH3. Now we get this products, and then now on when further oxidation takes place, this is a ketones. Ketones do not undergo further oxidation reaction, but for aldehydes undergo oxidation reaction to produce acids, carboxylic acids. Therefore, when these aldehydes undergo oxidation reaction, CH3 COOH, acids are produced in this way when hot KMnO4 undergoes oxidation reaction for the oxidation reaction of alkenes. Now let's check out another chemical reaction of alkenes, that is addition of water, is also known as hydration. Now what is addition of water? Now the alkenes when it adds up with water, alcohols are formed in this process. Now we know that water in the presence of sulfuric acid is used to produce alcohols when hydration reaction takes place in alkenes. Now even in this, the hydration of alkenes, Markovnikov's rule is followed. Now in this reaction, we know, if we take here another example, CH3 CH double bond CH2 in the presence of H2SO4. Now H2, we know that water can be broken up in this way. Now the H plus attacks the carbon atom having more number of hydrogen atoms, and OH minus attacks in this the carbon atom having the least number of carbon atoms. Therefore we'd be getting here CH OH, and then this CH2 would become CH3. Therefore in this process, hydration of alkenes takes place. Now let's check one more example of hydration reaction. CH3 CH CH3 CH CH2. Now H2SO4 H2O, the H plus OH minus comes here, the H plus attacks the carbon atom here. Therefore we'd be getting here CH3 CH, this H, let's write it up there, CH3 CH. Now this, the double bond breaks up, checking the formation of a carbocation, because when Markovnikov's rule is followed, a carbocation should always be formed. But if anti-Markovnikov's rule is followed, free radicals are formed. This goes here. Therefore this carbon atom would have a positive charge, and then we would be getting here CH3. Now we know that this is a secondary carbocation attached to carbon atoms. Therefore secondary carbocations, the tertiary carbocations are more stable than secondary carbon. Therefore now to get a tertiary carbocation, there would be hydride transfer, means the transfer of this hydrogen, hydride transfer. There would be hydride transfer reaction would take place. Therefore if this hydride is transferred to this position, then we would be getting our CH3 CH3. This carbon would become positive charge. This would become CH2, and then this would be CH3. Now this is a tertiary carbocation which is more stable than the secondary carbocation. Therefore it reacts with another molecule of water. The OH minus comes and attacks here. Then we'd be getting our product here, CH3 C, the OH came and attached here, CH3 CH2, and then CH3. Therefore in this process the hydration reaction of alkenes takes place. Now let's check the last chemical reaction of alkenes, that is polymerization reaction. Now what is polymerization reaction? Polymerization reaction is the formation of polymers when small monomer units are joined together by chemical combination, that is polymerization. Now CH2 CH2, this is our ethene molecule. Now when n times n monomers of the ethene is used undergoes polymerization, that is at high temperature and pressure. When a catalyst is used, we'd be getting here CH2 n times of the ethene molecule, therefore we'd be getting here polyethene. In this way, the polymerization reaction of ethene takes place to form polymers, means monomer units, small monomer units join to form the polymers, or small units join together by chemical combination or by polymerization to form bigger units. In this way, the polymerization reaction of alkenes takes place. Therefore, this is the last chemical reaction of alkenes.